All right, boys and girls, welcome back to the drive-thru. Hope everyone's off to a good start this week. As always, the drive-thru is sponsored by the deli. Hungry? Stop by the deli. Make yourself a peppered turkey sandwich on 9-grain wheat with American cheese, toasted, and a bag of Cheetos. All right, so this is our first shortcut proof we've ever put on the In-Your-Net. We are given a whole bunch of information regarding this picture right here, okay? So we know that FH, this whole segment, is congruent to FK from here to there. Okay, we are also given that angle H is congruent to angle K. Okay, and then we are given that G, M, and J are all midpoints. We're not going to mark our picture yet because midpoints, we have to make another statement. And this is a great chance. For example, a lot of you missed 1 point on the quiz because you're confusing like angle division with definition of trisect. Well, here's a great opportunity for us to understand when we're going to use segment division and when we're going to use definition of midpoint. Okay, we're going to use them two different ways. We're trying to prove that these two triangles are congruent to each other. Okay, we have three different shortcuts that we can use. We're given an angle, so in my mind, we're not going to be using side, side, side on this one because we were given an angle. So we're either going to be using angle, side, angle, or what else? Or side, angle, side, okay? All right, one. So I'm going to squiggle my givens to save all of you that are watching this video time. Okay, so all of these things that I have typed out right here go right there. Okay? Now, notice that these two big segments are congruent, but G and M are the midpoints of those congruent segments. So we can directly, in one step, say that which two segments are congruent to each other. Cole? Excellent, Cole. So we're going to say that GH is congruent to MK with our second step. GH is congruent to MK. Now, is that the definition of midpoint, or is that segments division? Very good. It's segments division. As an if-then statement, segments division says, if two segments are congruent to each other and they are divided, that the resultant segments are also congruent to each other. Okay? All right. Well, J is also the midpoint of HK. So what could I deduce from that statement? Kev?
Segment HJ and segment JK are congruent.
Segment HJ is congruent to segment JK. Or KJ. I could say it either order. Now that's a different reason. So what's that reason, Kev? Excellent. So I hope right there that I just helped some people in here that might be a little confused on when to use which one. It's just a point. It didn't make you or break you on the test, okay? All right, well, look what we have now. Do you see how marking the diagram helps us to use the shortcuts properly? So now I can say that triangle GHJ is congruent to triangle MKJ and my reason will be the side angle side postulate, and that's how we're using these shortcuts. Hopefully that helps. Boom!